The purpose of this lab was to identify the limiting reactant by measuring the precipitate in 8 test tubes at different ratios of 0.2 molar potassium hydroxide and 0.1 molar copper sulfate and observe their chemical reactions. In this lab, the balanced chemical equation that represents the reaction is 2 moles of KOH plus CuS4 yields K2SO4 plus CuOH2. The mole ratio of these two reactants is 2 to 1, meaning that for every 2 moles of potassium hydroxide, there is 1 mole of copper sulfate to create a certain amount of yield, which is 1 mole of potassium sulfate and 1 mole of copper 2 hydroxide. Molarity is the number of moles of solute divided by the number of liters of solution, which measures amount, unlike volume, that measures the space occupied. A limiting reagent, or reactant, is a substance that is totally consumed when a chemical reaction is complete, while the other reactant is left over. This also limits the amount of product that can be formed. Additionally, the precipitate is an insoluble solid formed during a chemical reaction within a liquid.
Materials. To recreate this lab, you will need 0.2 m potassium hydroxide in one burette, 0.1 m copper sulfate in another burette, 8 test tubes, spatula, and a ruler. Let's fill 8 test tubes with 5 milliliters of copper sulfate, and start with 1 milliliter of potassium hydroxide in the first tube, adding 1 milliliter for each until you have 8 milliliters of potassium hydroxide in the 8th tube. Then add water to each tube so the solution will have 13 milliliters in total. Start by adding 7 milliliters in the first tube and then decrease it by 1 milliliter of water until you don't need to add any more for the 8th test tube. Allow the test tubes to sit for 15 minutes and lightly stirring. Measure the precipitate of each test tube after 15 minutes.
Observations and data. Before the chemical reaction, potassium hydroxide was a clear liquid and copper sulfate was a blue liquid. Both reactants were electrolytes. After the chemical reaction, the product formed contained a precipitate, CuOH2, making it look flaky or powdery. There was also a liquid in each test tube, which was the other product dissolved in water, K2SO4. Test tube 1 contained 5 millimeters of precipitate. Test tube 2 contained 8 millimeters of precipitate. Test tube 3 contained 11 millimeters. Test tube 4 contained 35 millimeters. Test tube 5 contained 40 millimeters. Test tube 6 contained 38 millimeters. Test tube 7 contained 42 millimeters. Finally, test tube 8 contained 35 millimeters of precipitate. Discussion. The limiting reactant is potassium hydroxide for test tubes 1 through 4. Based on the chemical equation, the perfect mole ratio is 2 moles of KOH to 1 mole of CuSO4, which would yield 1 mole of each K2SO4 and CuOH2 and have no excess. However, in the first 4 test tubes, there is not enough KOH to make as much product as possible with the amount of CuSO4. For instance, in test tube 2, the ratio of KOH to CuSO4 is 0.000 moles of KOH to 0.0005 moles of CuSO4, making this smaller than the perfect ratio 2 to 1. Based on the molarity of each reactant, 0.2 molarity for KOH and 0.1 molarity for CuSO4, the perfect mole ratio of 0.0010 moles of KOH and 0.0005 moles for CuSO4 can be seen in the 5th test tube. As the amount of KOH increases, CuSO4 becomes the limiting reagent for test tubes 6, 7, and 8. For example, in test tube 7, the ratio of KOH to CuSO4 is 0.0014 moles of KOH to 0.0005 moles of CuSO4, which is greater than the perfect mole ratio of 2 to 1. Therefore, as the amount of KOH varies, the limiting reactant changes. Possible errors are misreading the lines and increments, indicating how many millimeters were dispensed on the burette, and accurately measuring the amount of water in the graduated cylinder. Another possible error is not allowing sufficient time for the precipitate to settle. If we had waited longer than 15 minutes, the precipitate might have settled more, and its height may have been more accurate, leading to more precise results.